I recently added LED lighting to an old Lima Class 37 covered in another video. Because it's a DC locomotive, I experienced LED flicker due to the back EMF current from the motor. I thought I would share more detail on this as I found it tricky to overcome. Whilst the locomotive is running in the forward direction, the red LEDs should be unlit, but here you can see them flickering. The solution I landed on was to wire a capacitor across each LED circuit in parallel, then a resistor across each capacitor to discharge the capacitor quickly. To test the concept, I connected a pair of red LEDs, each wired in opposite polarity to the other. The LED on the left is not protected from back EMF and is suffering flicker. The LED on the right is protected from back EMF, with a capacitor and resistor wired across it in parallel. Although not quite perfect, it proves it will work with further tweaks. The final suppression circuits would look like this: a polarized 47 microfarad 100 volt capacitor, with a resistor across the terminals, and diodes fitted to protect against reverse voltage, mainly where the locomotive direction causes the circuit to face the opposite polarity. So here is the circuit diagram for the locomotive. Forward and reverse lighting wired in series. Three console instrument LEDs also wired in series. 2 LEDs wired in parallel for a cab light and backlight for the dials. So now you have the 4 LED circuits. Each one has a back EMF suppression circuit wired across it. Note that the reverse direction lighting is wired in opposite polarity. Resistors were used to limit the current on the directional and instrument lighting. 1000 ohm resistor size achieved the desired brightness, and 470 ohm for the cab light and dial backlight. Each back EMF suppression circuit has its 47 microfarad capacitor. I initially tried the small ceramic disc ones, but they were not big enough. I may have got away with less than 47, but I already had these and they did the job. Each capacitor is protected from when the motor is running in opposite polarity. This is achieved by fitting a diode on the negative leg of the capacitor. To avoid any discharge into the LEDs, I also fitted diodes to the positive legs, but I think this was probably unnecessary. A resistor was wired across each capacitor. This allows them to discharge quickly so they keep soaking up the back EMF current. The resistor size is key. It is a balance between sending current through the suppression circuit and the LED circuit. The lower the resistance across the capacitor, the more voltage is required to light the LEDs. To find the required resistance, I strung together a chain of 1K ohm resistors. I moved my test lead along until I had the desired effect. Slowly turning up the power, the LEDs need to light up just before enough voltage is produced to start the locomotive moving. For the directional lighting and instrument lights, which are all wired in series, it was 10K. And for the cab light and dial backlight, which are wired in parallel, only 1K was required. Now all the suppression circuits are made. The top of the capacitor with the 1K resistor is marked red for identification. Everything is now wired into the locomotive. Fortunately, there is plenty room inside the body, but it was still a fiddle. And as you can see, LED flicker is completely eliminated. There are probably better ways to do it, but this is what worked for me. Job done.